All right, this is Algebra 2. Our topic today is 1-4, solving equations. Yay! So we're bringing it together. We're doing the classic algebra, solving equations. Make sure that your header matches my header. I'm Leah. We're incorporate today the date. And our learning objective is to solve equations and to solve problems by writing equations. And just for reference, you don't have to write this down, but just for reference, an equation is a statement that two expressions are equal. So the equation has an equal sign. Our essential understanding, you don't have to write this down either, is that you can use the properties of equality and inverse operation to solve equations. So all those little operations we're going to use, properties of equality and inverse operations, we are going to be math ninjas and use those and solve our original equations. All right, so what I want you guys to do is write down each of these properties, because these are the properties of equality that we're going to use to manipulate our equations. So the first one is reflexive. That is just one item is equal to itself. I think of it like a little mirror here, like a reflection. That's how you know it goes with reflexive. Symmetric property is if A equals B, then you can rewrite that as B equals A. It has a symmetry to it. Transitive, I think of this like a hobo person. You kind of wander here and kind of wander there and get to the end. So if A equals B and B equals C, then you can say A is equal to C and cut out the middleman, kind of a wandering hobo on there. Transient, transitive. Hey, don't judge. Substitution is when you take out one item and put in something that has its equal value. So if A is equal to B, then we can replace A with B and vice versa. I want you guys to come up with your own examples for this. Addition, property of equality. If A equals B, then I can add any number C to both sides of the equation and keep my equation equal. Subtraction property says I can subtract any amount C from both sides and still get an equation that is equivalent. Division, multiplication properties, I can multiply both sides by one item, by C, any value C, and still get an equivalent statement. And division properties, I can divide both sides by the same amount and still preserve the equality of the equal sign. Okay, so make sure you write down all these properties. Make sure you have them written down in your notes. All right, so the solution of the equation, write this down in your notes, is all values of the variable that make that equation true. That is the solution, all values of the variable that make the equation true. An inverse operation inverse operations are operations that undo each other. Adding 1 will undo a minus 1. Dividing by 2 will undo a multiplying by 2. Those are inverse operations. All right, so we are going to take a moment and I'm going to solve each of these equations. I picked a variety of different kinds so that you can see how to do each of the inverse operations. So I'm looking at this, h minus 12 equals 6, and I want to solve for h. So I'm going to do the opposite of minusing 12, and I'm going to add 12 to both sides. When I add 6 to 12, I get 18, so h is equal to 18. Here for this problem here, negative x over 3 equals 27. So I'm going to divide, right now I am dividing by negative 3. So the opposite of that is going to be to multiply by negative 3. The negative and a negative become positive, and 3 divided by 3 leaves me with just the x. 27 times negative 3 is negative 81. That is the answer. All right. Over here at 4t equals 48, I have 4 times t. The opposite of multiplying by 4 is dividing by 4. And 48 divided by 4 is 12. Here I have 22 plus r. Well, thank goodness r is positive, but really I want to undo this positive 22. So I subtract 22 from both sides, and I got r equals 14. All right, last but not least, I have this little equation here, 2 minus 3 parenthesis x plus 4 close parenthesis equal 8. The first thing I'm going to do is I'm going to attach this negative onto the 3. He is together, he is a buddy with this 3, and I'm going to distribute that negative 3 into, I'm going to give that negative 3 times x to get negative 3x. And I'm going to go negative 3 times 4 to give us negative 12. Then I'm going to simplify that into 2 minus 50, the 2 and the minus 12 go together. So 2 minus 12 is negative 10 minus 3x equals 8. I'm going to rewrite that here so I have more room. I'm going to add the 10 to both sides. The opposite of minus 10 is plus 10. And I'm essentially solving for x. Then to get rid of the minus 3 in front of my x, because you're multiplying, I'm going to do the opposite of multiplying. I'm going to divide by negative 3. And 18 divided by negative 3 is negative 6. All right, so that's how you use inverse operations to solve equations. This next problem is our other part of our learning objective is to create word problems that model and to model problems using equations and solving. So 2 planes left an airport at noon. One flew east, so here's the airport. One flew east, and the other flew west. At twice the speed. So if my speed is r, so if this is r, then west guy is flying at 2r, where r is your rate. After 3 hours, so the time that we've spent is 3 hours for both airplanes. The planes were 2,700 miles apart. So essentially, if you look, plane 1 has a distance 1, a rate 1, and a time 1. Our formula is distance equals rate times time. Plane 2 has a distance 2, a rate 2, and a time 2. And he is distance 2 equals rate 2 times time 2. If you look, the two distances, the distance of the first plane and the distance of the second plane, they total 270 miles. That's how far apart the two airplanes are. Time 1 is equal to time 2, which is equal to 3. And rate 2 is equal to twice the rate of 1. So we're going to use these properties and put them together into a little equation. So I know D1 plus D2 equals 2,700. So let's go ahead and find what D1 is equal. It's equal to our rate, R1, times our time, which we know is 3. because it's 3 all day long. And our D2 is equal to our rate 2, which is 2 times rate 1 times 3. So D1 equals 3R1, and D2 equals 3 times 2 is 6R1. The two of those added together, so I'm going to use substitution. I'm going to replace D1 with our rate, 3 times our rate 1, and D2 is 6 times our rate 1, and it's equal to 2,700. Now I have like terms, 3R's plus 6, 3R1s plus 6R1s give us 9. Rate 1 equals 2,700. I'm going to divide both sides by 9 to get rid of the 9 with the R. So I know my rate 1 is 27 divided by 9 is 3, and the zeros hang on. So my rate 1 is 300 miles per hour, and my rate 2 is double that. And it's 600 miles per hour. This is the maximum difficulty you guys are going to experience in creating an equation. But it all started with distance equals rate times time, and then substituting in. All right, for these problems, we are going to determine whether the equation is always, sometimes, or never true. So if I get, so the first thing I'm going to do is I'm going to solve this equation, 8x minus 12 equals negative 12 plus 8x. I'm going to add 12 to both sides, and I get 8x equals 8x, and this is always true. When I get a statement that is exactly the same on each side, then we know it's always true. This guy, let's see if he is always, sometimes, or never true. 2 times 5x is 10x. 2 times 4 is 8. I get 10x plus 8 equals 10x plus 6. I'm going to minus 10x from both sides. And I get 8 equals 6. This is never true. So if I were to get a point, so if I were to get x equals 4, that would be the third scenario where it's sometimes true. All right, last but not leastly, let's solve this formula for g. So I'm going to, the first thing I'm going to do is multiply by the 2 to get rid of, which is the reciprocal of 1/2. And then I'm going to divide by t squared, which is the opposite of multiplying by t squared. So the 1/2 and the 2 give me 1. T squared divided by t squared gives me 1, and I'm just left with g, and it's equal to 2s over t squared. All right, so for time constraint's sake, we won't do this last problem. But you want to make sure you're using those inverse operations to solve for just the letter you want. You leave that letter alone and solve for the rest of them. That's it for today.